Welcome, everybody. So today we are going to be starting to talk about energy. And the thing that I want to start with is talking about kinetic energy. Now, kinetic energy, as you might be able to guess from the name, is energy that is associated with the motion of an object. The object that I'm going to play around with today is a book. So I'm going to think about a book here. I can kind of toss the book around, move it around with my hand, that sort of thing. Anytime it is moving, this book will have some kinetic energy. That kinetic energy will depend both on how much mass the book has, so little m, and the speed of the book. So how fast is it moving? The particular form for kinetic energy is 1/2 the mass times the speed squared, so 1/2 mv squared. We'll typically use the symbol capital K for the kinetic energy. One interesting thing that you can see here is that it looks like the speed has a greater impact on the kinetic energy than the mass does, which means if I take my book and I move it around faster, right, compared with moving it around slower, that's going to give me a bigger kinetic energy than if I took a whole stack of books and moved them around at that slower speed. Right, so that's kind of an interesting result about kinetic energy. One thing to note here is that kinetic energy, unlike many of the quantities that we have played around with in the course so far, is a scalar quantity. It is not a vector, which means that it actually ends up not depending on the velocity, right, on what direction the object is traveling, but only on how fast they're moving, right? So moving this way, or this way, or this way, or that way, at the same speed is all the same from the perspective of kinetic energy.